Have you ever looked up at the sun and just wondered, how do we get that massive ball of energy to power, say, your laptop right now? Well, that's exactly what we're going to do. We're going to follow a single ray of light on its incredible journey, all 93 million miles from the sun, right to the socket in your wall. Let's get into it.
Okay, just let that sink in for a second. In about the time it takes to watch a movie, the sun beams more energy down to our planet than every single person on Earth uses in an entire year. It's a mind-boggling amount of free, clean power just washing over us every single day. The potential there is just wow.
So that's the billion-dollar question, right? How in the world do we actually catch that energy? Well, the answer starts with something you've probably seen 1,000 times, but maybe never looked at quite like this. And here it is. Our journey begins with the solar panel, sometimes called a solar module. This thing is the front line. It's the workhorse of the entire system. This is where that sunlight, after its long trip through space, finally gets to work. Now, the magic that happens inside these panels all comes down to a scientific principle called the photovoltaic effect. It sounds super technical, right? But it really just boils down to its name. Photo, which means light, and voltaic, which means electricity. It is literally the process of turning light directly into electricity. It's the absolute heart of solar tech. So let's break this down. First, little particles of sunlight called photons slam into the panel's silicon cells. You can think of them like tiny cue balls in a game of pool. They hit the silicon and just knock electrons loose. Now here's the clever part. The silicon is layered in a way that creates a sort of one-way street, or a slide. This internal electric field forces all those loose electrons to flow in the exact same direction. And that right there, that directed flow of electrons is electricity. Specifically, it's what we call direct current, or DC power. Okay, great. So we've made DC electricity. We're done, right? Well, not quite. See, there's a problem. Your TV, your fridge, your phone charger, pretty much everything in your house doesn't run on DC power. It all needs AC, or alternating current. So that means we need to convert it. And that brings us to the real brains of the operation. Meet the inverter. I love this analogy. It's basically the system's universal translator. The solar panels are speaking one language, DC, but your home only understands another, AC. The inverter's entire job is to take that raw DC power and translate it instantly into the AC power your home can actually use. It's the crucial link that makes this whole thing work in our daily lives. Now, you've got a few flavors here. The classic is the string inverter, one big box that handles a whole string of panels. It's cost-effective, but if even one panel gets covered by a shadow, it can bring down the output of the whole group. To fix that, you have microinverters. Each panel gets its own tiny inverter, so they all work independently. This is a game changer for roofs that get some shade. And then there's a hybrid approach called power optimizers, which fine-tunes the power from each panel before sending it all to one main inverter. Kind of the best of both worlds. So we've covered how we create the power and how we convert it. But what about the stuff that physically holds it all together? And what happens when it's a super sunny day and you're making way more power than you can even use? That brings us to the backbone of the system, the racking and the storage. First up, you have racking. This is literally the skeleton that holds your panels in place. For most homes, a roof mount is the way to go. I mean, you're using space that was just sitting there anyway. But if you have the land and your roof isn't quite right, a ground mount can be amazing. It lets you position the panels at the absolute perfect angle to the sun for maximum power. And what about all that extra juice you're making on a sunny afternoon? Well, instead of just sending it away, you can save it. And that is where a battery comes in. The best way to think about it is as your own personal power piggy bank. You store up all that excess solar energy from the daytime so you can use it later, at night or maybe during a power outage. So when does this piggy bank really make sense? Well, if you're living completely off-grid, it's not optional, it's essential. For the rest of us, it means you have power when the grid goes down. It means you can use your own cheap solar power in the evening instead of buying expensive power from the utility. And, when you get right down to it, it's the key to real, true energy independence. Okay, so we've looked at the panels, the inverter, the racking, the battery. We've met all the individual players. Now let's put all the puzzle pieces together and see how they create one seamless, really elegant system. So here it is, the whole journey one more time. Step 1. The panels capture sunlight and make DC power. Step 2. The inverter transforms it into usable AC power. Step 3.
That power gets distributed through your home's breaker box to your lights and gadgets. Step 4, if you're making more than you're using, that extra power charges up your battery. And finally, step 5, if your battery's full, any leftover power gets sent back to the grid. And in many cases, you actually get credit for it on your bill. It's a perfect clean energy cycle.
So let's end on this thought. Every single day, your home, my home, our entire planet is just bathed in energy from this massive, clean, and totally free power source in the sky. We've just walked through exactly how the technology works to harness it. Really, the only question left is, isn't it time we started using it?